Now the exercises are a little. That's another thing that you're going to have to get used to. I think is that the way that they're set up in the course. Let me go to content and go to session two. Yeah, session two, and you'll notice that there is first of all there was exercise 2A. Oh, did I compact it here? I went back to session one. There was exercise 2A, which is an Excel exercise. We did that in a live class. We did that in a live class. Matter of fact, I recorded that. So that review, that exercise in Excel, that's available to both the in-person class and the online class. If you look in the announcements, I posted the recordings of most of the in-person class. So you can actually see me work through that exercise. And most of the next exercise, lab session 2B, that's really intended for you guys to go through on your own, or if you're in a live class, to go through together as a group, right? And which is literally like an exercise, not graded or anything like that. However, the second part of this is sample. It says sample code for instructors. The intention there was for that to be hidden. I can hide that so you can't see it. Okay. And the intention there is that's the portion of it that you would have to run in order to get the answers to problems 5 and 6 that we just looked at. However, my feeling is that this is not a course in art, it's a course in biostatistics. So while it's nice to challenge you, what I suggest you do is you try and answer those questions on your own. And if you're stuck, go there, retrieve that code that's in there that's meant for me. I guess they, it was meant for me, because they figured, well, maybe I wouldn't be able to figure it out on my own. So we want the instructor looking like a dope. So here, we'll give him the code that you need to, to figure the code you need to answer those couple of questions. Okay. So there you go. So in other words, this is going to have the data, the various commands you're going to have to use to do that. Okay. In other words, you have exercise up to 6, 1 through 6 on the first part of this exercise, and then 7, 8, 9 here. Okay. And that 7, 8, 9 is probably what you need to answer those questions. We'll actually see that if we go through these. So, any other questions? I hope I answered that question. Did I answer the original?
Yeah, definitely.
Okay, good.
Thank you, Professor Vito.
I forgot. I got carried away and I forgot what it was.
No worries at all.
Okay, good. So if we don't have any direct questions on the quizzes and stuff like that, I'm going to go through that R exercise because I think that this is the stuff that you guys probably find most challenging. You guys can look at the PowerPoints, play the videos, and so on, and I think like figure out most of the narrative questions. But a lot of people feel uncomfortable with coding, which is even though you're using a nice interface like our studio, it's still some amount of coding going on there. And especially at the beginning of this class, it can be a little bit challenging to understand what's going on. So let's actually do that. I was going to start from with the in-person class. I got about 2/3 of the way with the first exercise. So I was going to continue from there. But since I invited both classes, I'm going to start from the beginning again. So first thing I did was download those 2 exercises. Okay, and I'm going to go over here to the folder where I stored them. And the first exercise was basic. Nope, that was the Excel exercise. Like I said, if you want to see that, that's fully recorded on the recording of the online session, which both classes can find the announcements. This one, to a practice with data, that's the first exercise. The second exercise is let's see, is 2B, which is 2B answers. That's the other part of that. That's exercises 7, 8, and 9 that we're just looking at. Okay, so let me start with the first one. So this is the first one. I just double clicked and loaded it. I have a lot of other detritus here from other exercises. One of the ways, if I don't want to deal with that, one of the ways that I can get a fresh start with R is I can close this and either save it or not save it or whatever. And I can go up here and say that I want to create a new project. It comes up with this window where I can tell it to either save it into a existing folder or create a new folder to store it in. And I can say that I want to create a new project. And I can give it that folder, that I can give that folder a new name. So I could call this review session. Let's see, nine dash, what is today's the nine dash nine dash, oops, dash 25, right? And that'll create a folder on my desktop with that name. Bingo, like that. And bingo, it opened in a new window in R. Everything's gone. The data's gone. The present data set is gone, and so on and so forth. And now what I can do is I can first notice I only have three windows. I only have the programming window. I don't have the console, which gives us the output. That's actually tied in up here. So I'm going to click on this up here to separate those two windows, and now I can see the console down at the bottom, which gives me my results. Okay, so there we are down there. Okay, so now if I double click on, I can either go open and go to where I have that data stored, or I can that exercise stored. I could just double click on it again, and it loads it into my new project. So here I got my blank window, and I got my project, which is all by itself. No other detritus, like hanging around here. So okay, so now I am going to go through this. Now, this is intended for you to step through looking at these remarks. Anything after a hashtag is a remark. It's a comment. It's not executable code. And if I just highlight it and say run, it'll get ignored. It'll just get echoed here. It's not going to do anything with it. So that's not really code, but it's intended there and a lot of people, a lot of programs will use this so that they remember how they coded something so they can make modifications and use it as notes or documentation for other people that have to work on it. But in this case, we're using it as a training tool. So this is telling you, remember to run, code in R, drag the cursor over the lines, and so on and so forth. So it's telling you what I'm about. That line is telling you what I'm about to tell you right now, which is when you want to execute a command in R, there's two ways you can do it when you're using RStudio. One is to highlight the entire command with all the details that right there, like this is to clear out any memory, any variables that have been previously assigned that might be still hanging on, and click run. The other way you can do this, notice it's echoed down at the bottom in the console. If you don't get an error, it means it executed it properly. Okay, so the other way you can do this is click anywhere in this line at the end of the line, right? Not in this comment area or something like that, just anywhere in this line and click run. It does exactly the same thing. So you can highlight it or not highlight it. Okay, the next thing we see is the instruction that next thing we should do is install packages if needed. Packages are collections of commands, extended capabilities, even data sets that are available within these packages that extend the capability of R. One of the reasons why R is so popular is because it's an open source program, it's an open source tool, which means that it's basically free for people to download, use. They can even update it, can add capabilities to it. And literally tens of thousands of packages have been created by various users, particularly in certain areas of study like statistics. And those packages are available, are made available through a server, this CRAN server, which stores all of these. They're available for people to look at, modify for their own purposes, to propose adding to the mirrors for R so that other people can use them. Those are, you have a whole library of those things that you can go to and download. In this case, we're going to need some files and extended capabilities in order to run the commands we want to use in this first exercise. Okay, one of them is called tidyverse. Tidyverse has a whole collection of data files and basic commands that help us run certain kinds of statistical tests and organize data and so on in R. The other the package that we want to use is Open Intro. And this is a package that's been created by the statisticians that created our open source textbook, Modern Statistics. Also, they have another textbook literally called Open Intro Modern Statistics. They've created a package of extensions that are useful to use with the book. So we're gonna install both of these packages, and I can either highlight them completely and run both at the same time, or I could just do them click in them individually, add them. So now you see a lot of red type because R tends to be a little bit verbose. And just because you see red type doesn't mean that there's an error. Look for errors. You might get warnings. Don't worry about warnings. One of the things that you may see is a warning, for instance, that there's an updated version of Tidyverse. Okay, and it asks you if you want to replace the version that you have. I would suggest that you consider not doing that if it suggests it, unless you find that the commands that certain commands that you know should work, like exercises that we've given you, don't seem to work, then maybe you need to download the updates. But I would default on saying no thanks to that, because if you do install them, you have to restart, and who knows if our exercise is really compatible with the new versions of those packages. Now the packages now are available to us. Okay, so if I click on packages over here in this file window, I can actually find Tidyverse and Open Intro. So I'm going to scroll down here, and these are others that were loaded with RStudio. In other words, they're present and they're loaded with RStudio, and some of them are actually active by default. What was I looking for? I was looking for Open Intro. Here you go, Open Intro. So Open Intro is a package that's installed on our version of R right now. Notice it's not checked. That means it's here, but it's not available for us to use. I could just check it now, make it available. But more directly, you can actually do it in your programming window. And the way that you do that is you click on you use the command library, parentheses, the name of the package, which you've loaded already, is within the ones that are in here. Click run, and you'll notice that I may have to click out of here. I'm gonna say Open Intro. I'll click Run, and you'll notice that now Open Intro is checked off. That means now it's available for us to use. So you got to use both the install package and the library package. Now note, once you have installed a package, it's in your memory here in R. You don't have to install it again, but you do have to use the library command to make it active and use it. So if you start a new program, you start a new project, you don't have to reinstall the packages Tidyverse and Open Intro, but you do have to use the library commands to make them available to you. So the next thing we're going to do is we're going to work with a data set called New York City flights. And that's a collection of 30,000 different flights that took off out of the 3 New York City airports, and has recorded their departure time, their arrival time, and how long what was the original departure time, what was the delay, how long a delay did they have, and where were they flying to, what airports were they flying to, and what carriers were there, number pieces of data. So we need that data set to be available to us in order to do this. So when we get to session 3 or 4, we're going to learn how to import data sets from outside into R. But as it happens, in this exercise, we're using a data set that's been provided to us by one of these packages. And the way I'm going to note that it's there is I could just type in the name of the data set, flights. Note, first of all, number one, I know instantly that it's there because it's telling me what it looks like. But if it didn't do that, if I just continued to type flights and I hit run, it would display what that data set looks like. It would only display the first 10 values, and which display some of the variables as well. So what this does tell me is that this data set has 32,000 lines and has 16 variables. Notice it doesn't show all the variables, it doesn't show all the lines. It only shows us a quick look at this data set. Okay, another way to get the same thing is to use the command data and parentheses the name of the file, click run, and we get, now it's pulled that, what it's done is it's taken that data set and pulled it into our environment window. So put it in here. So I can click on that and I can actually look at this. I can open that data set up and actually look at it, right? So there you go. I just double clicked on it. There's the data set. It shows me all the columns, all the rows, all the data. is all in there in there. That's what that data parenthesis, the file name did for us. So, and notice we got a new tab up here, which is because I double clicked on it, put it in a new tab. I'm going to go back to our lab, which is still up there. So now I'm going to use another command called names, and I want to know the variable names for the New York City data set. I already know that there's 16 variables. Going to click run, and here's the names of the variables. It lists us down in the console window. So we've learned a couple of things. Data, New York City flights will put the data set into our environment so we can look at it. The command names will give me the variables for that data set, and the argument, it has like details that it needs to execute. Those are called arguments. The command name is name, and the argument is the data file name, which is New York City flights. Okay, so that's what that does for us. Now, so we've learned two commands, right off the bat. We've learned number one, how to take a quick look. We've learned one command, two commands. As we go through this, what you are doing is you are building your own library of commands so that you can use them in the future. So when we're working with a different data set, you know how to get the variable names. You know how to get a glimpse of the data or pull it into your environment window, and so on. And next one is just question mark with the data, with the file's name. What's that going to do for us? I'm going to click run, and it's going to bring us over here to the help viewer. And the help viewer, notice how we were in files, we were in packages before. Now I'm going to click on help. The help viewer, when I say a question mark at New York City flights, the help viewer takes us over to a description of New York City flights, which, by the way, came from the package open intro. Now we know which of the two packages contain this data set. Okay. And it tells us what the format is, what the different variables are, how the different variables are formatted. The variable flight is the flight number. The variable origin, dot destination is the origin and destination. The air time is the amount of time spent in the air, the distance, and so on. Okay, so this actually gives you a code book or a description of what all the variables that are represented here. So that's the command glimpse, right? That's going to do that for us. So now let's say that we want to plot this data. What we're interested in is one of the variables is the distance, arrival delay, departure delay is one of the variables that we're interested in. We have that variable. That's the name of the variable. The data set is New York City flights. The variable name is departure delays. So if I look up here, we are saying, okay, let's take a look at departure delays. That's just a comment. They could have put in here, let's produce a graph of departure delays. Okay, could put that in, give you a little bit more of an idea what's going to happen next. But you can kind of see that the command that they're going to use, and again, we got another command that we're learning that's in our memory, that we can actually start a list on the side, just like, if you have a piece of paper, right? ggplot. What does that do? Or you guys don't use, I'm old, so I use paper. I still use pencils, so you guys probably don't own a pencil anymore. So at any rate, so you can use ggplot, right? This command to create a graph or a plot. Okay. And how does that work? Well, again, what are the arguments here? The first argument is, what is the data I want to plot? So you put in data is equal to, and you stick the file name in there. Only things that are going to change when you use this again is the file name. And then you're going to tell it what you want to plot. AES roughly stands for the word aesthetic. In other words, we're going to create a graph. What are the variables that we want to graph? What is the variable we want to graph? And the variable we want to graph, X, is equal to departure delay. Well, why bother to say X is equal to departure delay? Only one variable I want to work with. Well, that's because some of the graphs we're going to want to make, for instance, a scatter plot, we're going to tell it, use the x-axis is going to be this value, the y-axis is going to be this. So you might have an x variable that represents x and a variable that represents y for each one of the subjects, each one of the lines of data. So in this case, we only have one. We say x equals departure delay. Then we say plus, which means I want more detail. And the more detail I want is to create a histogram. Now, we talked about histograms first session. Probably you've seen that either by watching my in-class video or by playing Dr. Schooling's videos. So you have a pretty good idea by this time what a histogram looks like. So a histogram means we're going to create a histogram. Now, there's no extra arguments we're going to put in there right now. There may be others that go with this command that we could put in there that describes maybe the color and so on and the labeling or something like that. But right now, we just want to create a simple histogram. So what is that? We're plotting a departure delay in the histogram. That's pretty clear. That's what we're doing. So I got to click there anywhere in there and let's see what happens. Click run and bingo. Sure enough, we have created a histogram. If you want, you can click on zoom and you can get a closer look at it. Okay, now look at this. One of the problems here is that, gee, I don't really see doesn't look like a normal distribution at all. In fact, it really isn't a normal distribution. However, everything's bunched up at this end. Why didn't it spread it out? The reason why it didn't spread it out is because although you can't see it here, because here you can see that's kind of a line there. There's 32,000 flights represented here, and this is 0 and 10,000. If there's only one flight that was 1,200 minutes late, it would be all the way out here, but you wouldn't even see the thing and wouldn't even be a pixel on this graph. But it still wants to graph it. So that outlier is causing this graph to go from 0 to 1,300 or something like that, right? So that's why this is all bunched up. Most of the values are all bunched up here. There are ways for us to deal with that. One way is to eliminate the outliers if we want. So it'll spread this out over a more reasonable, maybe 0 to 500 or something like that. So it gets spread out a little bit more. But we can see the majority of flights take off on time. And even then, when they're delayed, they're not delayed a whole lot. They're delayed, maybe this represents 10 to 20 minutes and so on and so forth. This is 100 minutes right here. So, no, I'm sorry, it's 250. So they take off maybe an hour late or something like that. And in fact, if you look carefully, it doesn't really start at 0. There's a lot of values to the left of 0. A lot of flights take off ahead of time. If you guys fly very much, you know that if they get everybody in their seat, they close the doors, they take off early, right? Because they got to keep on schedule. Because they have to wait in line in New York City airports to take off. So they want to get away from the gate as quickly as they can. And a lot of times they will close the gate 5 or 10 minutes, the door 5 or 10 minutes early. And if everybody's in their seats, and then proceed to, fly out. Okay. And for those of you who have ever missed a flight because you got there only 10 or 15 minutes before the flight was going to take off, you know that they closed that door at 15 minutes before the departure time, right? And if you ain't in that plane 15 minutes before the departure time, there's a good chance you're not getting on that flight because they won't open that door again. So anyway, so that's where we are. So a lot of these flights are, the vast majority of flights are on time, even possibly early. Okay, so that's good. We learned something. We learned two things. We learned a little bit about the distribution of departure delays on flights out of New York City. This means all flights, all different airports, all carriers, right? We didn't distinguish that yet. And we learned how to use the command ggplot and to use it to create a histogram. So next, I'm going to say to myself, that's very nice that I created that. But now the bin width here, right? This bin width is like, this bin width could be like, I don't know, like 50 or something like that. Let's tell it I want the bin width to be smaller, right? I want more definite. I don't want just one big square things here. I want this broken up. So now we can use the same command, except just change one thing. In here, we can add an argument that says bin width equals 15. I'm going to click on that and say run. And sure enough, if I zoom on this now, come on, cooperate. Well, you can see it here, right? It doesn't want to cooperate with me right now, right? So zoom. Come on. Okay, so anyway, you can see right here that the bin width now that's now been broken up, so I can see that this might be 15. This might be 15 minutes before departure. This might be within 15 minutes of departure, and so on. So the width of these bins now are 15 minutes, each one of these bins. So you can see a little bit more definition of distribution. So there's a small number of flights. There's a decent number. There's some flights that take off early. The vast majority of them take off roughly on time, and so on and so forth. Okay, so I can go back here and say the bin with 250. And that's even few. Remember, the first time we did it, we left it up to ggplot to decide how many bins to give us, what the width of the bins are going to be. But we can tell it what we want the width of the bins to be so that we can get a better look at the way that the data is distributed. So here, this is the first time that we've used the command and we've applied an argument that we can change in order to manipulate the results of that command. Okay, so everybody okay? Is everybody with me so far? Let me check the chat. Okay. Are you guys okay? Are you all with me? Let's see how we're doing here. Okay. I see a problem here. Okay. No problem. Okay, next. I'm going to go ahead. I'm going to go on to exercise 1 now. All right. So now I'm going to continue with this. Again, why are the 3 histograms different? So it discusses and gives you some feedback on it. Okay, so now let's take a look at another one. Let's narrow the bin width to really narrow bin width of 2. I'm going to click run. And now we can see there's a lot of different bins here. Okay, so let me see if I can't get this to blow up. Now, for some reason, it's mad at me and it's not doing that. Let me see if I can click out, click back in, click zoom. And maybe it's in the background. Oh, there it is. It's in the back. It was in the background. So now you can see all the different, you can see how many different bins here there are and how it's broken up and how the distribution here is a little bit more complicated than it looked when we didn't get that definition with the wide bins. So again, this is a tool that you have. Okay, so let's say that we want to get more specific. Let's say that we only want to examine the flights leaving New York City, the New York City airports, going to Los Angeles, going to LAX, Los Angeles Airport. So now what I can do is I can say to myself, let me create a new data file, which starts with all the flights, but now only has the ones going to Los Angeles. Okay, so what I'm going to do is I'm going to use this command, which says, take whatever's on this side and put it into this file. Okay, so, or into that value. So New York City flights, I'm going to take the file New York City flights, that's our data set with everything in it, all the flights in it, and run it through a process. That's kind of, you're going to say to yourself, I'm running it through some kind of process here. And that process is to filter the data. And how do I want to filter the data? Well, now I got to give that command filter, new thing we learned. I have to give that filter an instruction that I want the destination, the variable called destination, right? Remember that was one of the variables that we had, destination, is equal to LAX. That's the Los Angeles airport. Put it into quotation marks, parentheses. So now it's going to select only the flights to LAX and put it into this new data frame called LAX flights, this new piece of data called LAX flights. So I'm going to click run. And there's no error down here, just did it. It hasn't told us what it did yet, right? That we don't see it done. I could type LAX and, glimpse LAX and see kind of what it looks like if I want, but I'm going to assume that since there was no error, that it seemed to work, but I can check that now. I'm going to tell it to plot, except plot again, this time plot LAX, this new data set that we created, and plot only the departure delays for that and create a histogram. You can choose and tell it you can choose its own bin widths. So I'm going to click run. And here it is. Now this represents all of the departure delays for LAX. Now this is a much smaller data set. And it seems like the largest delay was about 350 minutes or so, right? 10 hours, right? On that particular flight. So you can see that, there were about 100 flights that took off early. And then the large majority of flights took off within a couple of minutes before the intended departure to maybe 5 or 10 minutes late, right? So that's the great majority of them. And while it's skewed to the right, it's a little bit more of an interesting distribution than we had before, right? If only for no other reason than we're dealing with a smaller data set, it's easier for us to see this, broken up into histogram. Okay, so now I could also go back in here and tell it, make this bin width, let's say make the bin width 5 and click run and see what that looks like. Oops. Okay. See if it did it for us. Did that change anything? Let's try something even smaller. I don't know if it actually did that. So you make it. Oh, I'm sorry. I didn't do that right. That's I have to tell it bin width, right? Remember, the actual command I got to put in is bin width is equal to. So one of the things you're going to find that you can do is you can take if you want to get if you don't remember exactly how to do something or it's complicated, you don't want to retype the whole thing, you can just copy and paste into the areas that you're working with. So I'm going to click this in here. Let's B, and I'm going to say make the bin width 5. And I'm going to run it again. And there we go. Notice how it changed our view of that. I can they say bin width 2 even if I wanted to. And here we go. We got really a lot of detail now on all the different flight delays and so on. Right. So you get a different perspective. Okay, so this reference gives you an opportunity to go in and take a look at the material that's in the textbook site. That's Open Intro, and get some background on what we're working on. Okay, so let's get numerical summaries, mean and median. Now we're actually going to be the first time that we're doing a real statistical function. We're calculating a descriptive statistics. The LAX flights, right? Okay, we have LAX flights. Let's find out what the median departure delay. That's a variable. That's a variable we're going to create. And what's the mean departure delay? What's the median departure delay? And what's the number of flights that are in the data set LAX flights? So we're going to take we're going to take this data set. We're going to put it through a process. That process is summarized. In other words, do calculations in statistics. Summarize. Give us we're going to create a variable mean underscore DD, departure delays, is equal to the average, the mean of the variable departure delay in the whatever it is, 1,000 flights out of the 32,000, the 5,000 flights LA. And then also calculate the median departure delay by calculating the value median departure delay. This is a command, right? This is a new variable. This is a new variable. This is a command that we're using to create this new variable. And the N is the sample size. N is defined as the sample size. It's going to click in here. I'm going to say run. Okay, it did it. And now it displays it for us. The mean departure delay is 9.78 minutes. The median departure delay is -1. What does that tell us? That tells us that more than 50% of the flights take off at least 1 minute, or 50% of flights take off at least 1 minute early. Right? Pretty interesting, right? So, and the total number of flights from New York City to LAX during the time period that they were recording this data, the 32,000 flights. During that time period, there were 1,583 flights to Los Angeles out of those 32,000. Okay, so now why is the mean? You can read that. Okay, so now let's do a histogram with a narrow bandwidth showing the departure delays. So okay, we just did that, right? I did it kind of ahead of the game, right? So you can see it's the same. It's the same one because I haven't changed anything there. Okay, filter. Okay, based on okay, now let's filter the database that we have, this New York City flights, on several criteria, not just where it's going, but also on the month that the month that the flight took place. So we're gonna take our New York City flights, our original data set. We're gonna run it through a process. That process is called filter, as we did before. And now we're going to tell it, we're going to give it arguments which tell it how we want to filter it. So we want to filter it so that we're only taking the destination value, the variable destination with the value SFO, San Francisco, and only with the month equal to 2, which is February. That's defined as or equal to. Okay. And with a comma in between. So a comma means and. So in other words, filtered into a new file called SFO February flights, and only the ones that have both both San Francisco and February in the variables. So I'm going to click on that. I'm going to click run, and it executes it. No hours down on the bottom. And now, if I want to see it, I can say, uh, um, 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 let's see how I can look at this. I'm going to copy this, and I'm going to paste it here. And I'm going to say, okay, instead of LAX, I'm going to change that to this. So I know I'm using the same command. I want to see the departure delays, which is departure delay, and I want the bin width to be. I'm going to make the bin width 5. Okay, I'm going to click in here, and we should see a plot that shows only the flights to San Francisco in February. And look, there we go. Right? Look how few that there are because we're only looking at New York City to San Francisco in that 1 month, in 1 month of all the data that we have. And now we can see, oh, look at this outlier here. And we can see why the mean was 10 minutes, but the median was only -1. In other words, the mean was 10. The average departure delay was 10 minutes because of these guys out here. And the median was the middle value was 1 minute early, right? So what does that tell us? That tells us that this data is skewed to the right because of these outliers, these very delayed flights. Okay, so let's take a look at exercise 2. Exercise 2, it's just a repeat of what we just did, right? So I'm going to click on that, do it again. So let's have a glimpse. Let's glimpse it. Okay, and there's the delays. Notice that the months, the variable months, only includes February's, and that the airport is a destination is all SFOs. So it really worked. We really did filter into that group. And you may also notice that there's only 68 rows. There's all 16 columns, right? All the variables are there. But there's only 68 rows because in February there were only 68 flights from New York to San Francisco, at least on the carriers that we included here. Okay, so at any rate, okay, exercise 3. What are we going to do in exercise 3? We're going to take that same data and we're going to change the bin width to 5. Click run, and we can see now it's much better defined. Except for those outliers, actually, the departure delays seem to be a little bit more normally distributed than we anticipated if we ignored all these extreme delays, the outlier delays. So it looks like some of these flights took off really early. At any rate, so they play a game with that, of course, because they always time these things so that they know realistically they're likely to take off early and arrive early. So it makes their on-time arrival statistics look better. So they do monkey with the numbers a little bit in terms of their prediction on departure and the prediction on arrival to make the delays seem make the data look a little bit better than it might be otherwise. Okay, again, let's do the same thing we did before to find the mean departure delay, the median departure delay, and the number of flights that are within this data set that only goes to San Francisco February flights. And I'll click run. And there we are. The median departure delay was -4.5 minutes, and the median departure delay was 11. There still are outliers, right? The median is still to the left of the mean, right? So we do know that there still are outliers out there, right? Which brought the average up to -4.5, but left the median where it was at -11. Remember, the mean is more affected by outliers than the median is. Median's hardly affected at all. Okay, so let's do some quick summary statistics. Except this time we're going to look at the let's look at the median and the interquartile range by place of origin. Okay, so what are we going to do here? We're going to take these San Francisco February flights, same database we've been working with that we're looking at in the plots here, and we're going to say group it by. We're going to run a process, and we're going to say group it by the flight origin. In other words, which airport did it take off from? and summarize the mean departure delay. The mean departure delay is equal to this variable, the median of this variable. The interquartile departure delay is the IQR. Again, this is a command, IQR, with the command arrival delays, right? With the variable name, we're going to take the interquartile range. We're going to take the mean of the arrival delays, right? We're going to take the interquartile range for the arrival delays, and we're going to take the number of flights. So I'm going to go ahead and do this, and I'm going to say run, and this is what we wind up with. So we have Newark and we have JFK, right? So I guess there are no flights flying out of LaGuardia that go to San Francisco. That's probably pretty likely. So what do we get here? The median departure delay from Newark was 15 minutes. Left 15 minutes early. That's the median. The median departure delay for Newark was minus 10, meaning it left 10 minutes. On average, half the flights took off 10 minutes early, right? The interquartile range, in other words, the middle 50% of the flights were 17 minutes late, or 20, the width rather. The width of the interquartile range is 17 minutes, and the width of the interquartile range for JFK was 22 minutes. That kind of tells us that the variability for JFK is greater than the variability for Newark. Although there were only 8 flights out of Newark, so that's not a very big sample size. There were 60 flights out of JFK. So we kind of got a bit of a look at the way that these are distributed. The interquartile range, they only gave us the 25th to 75th percentile. Middle 50% is what that departure delay represents. So the middle 50% of the departure delays had a range of 15 minutes. Remember the median is going to be in the middle of that range. So it's going to be the interquartile range is 17.5. It's going to be so the median is going to be half of that's going to be below 15.5, and half of that's going to be above minus 15.5. So you can kind of get an idea of what the range of the middle 50% is. But that's what that gives you. The 25th percentile to the departure delay for not the departure delay, but the range in number of minutes, whether it's early or late, the range in number of minutes for the middle 50% of the flights. And in fact, for Newark, it seems like most of those middle 50% were leaving early. Okay, so at any rate, that's a little bit hard to wrap your head around that. I'll leave it up to you to play with it a little bit. Okay, so exercise 4. Let's do this again, except let's group it by carrier, not by the airport, but by the carrier, the Delta, so on and so forth. Okay, so I'm going to click in here. It's going to group. It's going to perform a process. It's going to group them by carrier, and it's going to from a process on that. After it's grouped them by carrier, it's going to summarize the median delay, the interquartile delay, and the interquartile and the number of flights for each of the different carriers. So I'm going to click on here. You can parse this out. Parsing is kind of like, you remember when you learned in elementary school, you learned how to break up a sentence. You parse out a sentence into its different parts. You can look up the definition of parse, but you broke it up into noun, verb, object, and stuff like that. We're doing the same thing. We're programming, right? We're parsing this in the terms of the language of the program in terms of R. So we're going to take this data set. We're going to create groups by carrier, and we're going to ask it to summarize these statistics for each one of the carriers, each one of the members of that group. So I'm going to click run, and here we go. Sure enough, American Airlines, the median departure delay was 5 minutes. All the others, the median departure delay was a negative number. All the others tended to leave early. The least flights were whatever B6 is. Delta, the most flights was United Airlines from New York to San Francisco, at least anyway, in February, Was that in February? That was still in February. Yes. Okay, departure delays by month. So now we're going to do the same thing again, except we're going to go back to New York City flights. We're going back to look at all of the flights again. Now, remember, we haven't changed that original database. Whenever we've made a modification, we put it into a new data file. So now New York City flights, I'm going to group them by month, and then I'm going to ask it to tell me the mean departure delay. And I'm going to ask it to arrange the mean departure delays in descending order. So all of these are arguments based on this summarize command, right? We're describing what we want it to do. So I'm going to click in here anywhere. I'm going to say run, and here we go. It's in descending. Departure delays are in descending order, and let's see what month we're looking at. We're looking at see the worst is the average departure delay is worst in July, June and July, December, and then it starts to get a little bit better as we go through here. So I'm kind of surprised that February came out 10.7. But what these are around the holidays, right? That's when you get all three of these are during heavy travel months. December, the holidays, very heavy travel months. The summer, when school is out, very heavy travel. And then most of the other months, it's not quite so bad, especially September, November, October, September, October, November, school's back in session, right? It's not airports are not so crowded and so on and so forth. And then it gets busy. Then in January, February, things tick up a little bit because weather becomes an issue for a lot of destinations, right? But seems like the worst case is in these months when all those ratty kids are home from school, and we're going on family vacations, right? So, anyway, okay, seems the holidays. There we go. Yeah, it's just reiterating what I just said. So again, read the comments. I'm glad I'm glossing over the comments and giving my own commentary, but you can read the comments and see what you think of them. Okay, so now, suppose you dislike departure delays. You want to schedule your travel on a month that minimizes your likelihood of having a departure delay, so what we're going to do now is we're going to create we're going to take New York City flights. This time we're going to change something. Okay, we're going to take New York City flights and we're going to change something. We're going to use mutate means we're going to change something. We're going to change something and put it back into New York City flights. In this case, what we're doing is we're going to put a new variable into New York City flights. So instead of having 16 variables, now it's going to have 17 variables. So we're going to take New York City flights. We're going to run a process on it. That process is called mutate. That's a new instruction you can put into your library of instructions. And then the arguments we're going to give it is the departure delay is equal to, and we're going to put a statement in here. It's called if else. That instruction says that if this is true, then put this in. If this is not true, then put this other thing. If yes, then do this. If no, then do this, right? So if this or else, right? So if this is true, right, then if the departure delay is less than 5 minutes, put on time into this new variable called the departure type. If it's more than 5 minutes, in other words, if it's not less than 5 minutes, more than 5 minutes, then put in the value delayed. So this new variable is going to contain two possible outcomes, two possible values, on time or delayed. And that's going to be determined by if the departure delay is less than 5 or not. So I'm going to click in this, and it's going to put that new variable into our data set, New York City flights. So now we're going to have 17 variables. And click run. And sure enough, it did it for us. And now let's see if they did it, if we're going to do it here. Summarize. Yeah. Okay, what I'm going to do is I'm going to type in New York City flights. And I'm going to say, okay, I'll just say run. And if you look here, oh, I can't, okay, let's see if I can get that data, parentheses. I could use glimpse also, I think. I'm going to say run. Okay, and here's our new value here for New York City data flights. If I go over here, right? I should say 19, it should say 17 variables. If else, mutate. Let me run that again. Mutate, should have run it. Okay. And New York City flights, run. Let me double click on it and see if we have a new variable here. I don't see it. Why don't I see it? Okay, why didn't it work? Looked like it worked. If else, no, store it back in New York City flights, and New York City flights should have this new variable. Let me see if let's say names, parentheses, New York City flights, run, and arrival destination. What was the name? Departure type. I don't see it here. Something went horribly wrong. Let me try this. See if it creates a new file. Run. Okay. I tried to put it into the same variable and it didn't work. So I just told it, instead of overwriting, adding it to the original file, New York City flights, add it to a new file, create a new file called New York City Flights 2. And now that now should have everything that was in New York City flights plus this new variable. And and if you see it over here, you can see that it created that. And if I look at it, you can see now it has the departure delays listed here, right? So you'll be able to then summarize this to see if it actually affected your. Let's classify it into 5 minutes delayed, extra analysis. Choose the month with the lowest median departure delay. What are the pros and cons of the two choices? So okay, let's run this. Group it by month. Departure delays arrange by that description. I'm going to click run. Okay, and these are the months by itself. Now, okay, now we're going to plot it. And there is our plot. And see if we have anything else I can see here. Is this is repeating it? Did I scroll up inadvertently? Oh, now, yeah, I scrolled up. Okay, so this time I ran it and it worked, right? You can see it's got 17 variables. I'm not sure why that happened. Maybe there was a break. You know what it is? There might have been an extra carriage return or something like that. So it didn't really execute the whole command. But you can see now both New York City flights and New York City flights 2 both have the 17 variables that we're interested in. Okay, so ggplot, let's plot this again. Okay, and that's what we have. Oh, I must have it behind here. So this is plotting again the New York City flights with the departure delays. This is a repeat of what we did before. It's just a bin width of 10. So they went back to that. Okay, back to exercise number 5 on departure rates for New York City airports. We did that. I don't know why they're repeating this again. Group. Okay. Oh, something different happened here. Let's look at this command because this command is not a repeat of these others. So we're going to group by origin one of the New York City New York City airports by the New York City airports. We're going to summarize the on-time departure rate, and that we're going to create a new variable on the on-time departure rate, and it's going to be the sum of all the times it says on time in our new data set, right? New York City flights are our new data set, 17 variables. We're going to summarize, we're going to put into this variable on time that we're creating now, on-time departure rate. That's going to be calculated. We're going to calculate it as the sum of all of the times that we have on record on time in New York City flights and divide that by the total number of flights. That's going to tell us by origin what the by airport what the percentage of time that it takes off within 5 minutes of the departure time. Okay, so and then it's going to arrange a descending order of the on-time departure rate. In other words, which airport is best. And I already just ran it. I'll run it again. And look, LaGuardia. There weren't any flights to San Francisco, but there are plenty of flights out of LaGuardia. LaGuardia has the best on-time percentage rate at 72% of the flights. JFK was 69, and the least likely, the one with the lowest percentage of on-time departures was Newark Airport. That may not be a fair comparison because LaGuardia is probably a lot more local flights and probably fewer flights, where Newark is probably a lot more cross-country flights than there are in the other airports. And similarly for JFK, a lot of overseas flights from these two airports. No overseas flights from LaGuardia at all. I don't think. Yeah, it's not a. They don't have customs at LaGuardia, so they would never have any overseas flights from there. Okay, so exercise 6. Create a bar plot. Right now, segmented bar plot. Right, not a hexagram, but a bar plot. Okay, and the command for that is geometric bar. And we're going to use this data set, New York City flights, and we're going to say on our x-axis, we're going to want to see the origin, which is one of the 3 airports, and we're going to want to see the data is is departure type. In other words, on time or not on time. So we got to look at on a bar graph of what the relative on time is for each one of these. I'm going to click run, and there we go. It's a segmented bar plot. We talked about that in session 1, was it possibly? So if we look at this, the number of if we look at this has got to be, I got something in the way here, mine. So this first one is, come on, I'll zoom into it and make it bigger. Okay, so what do we have here? So Newark had the most flights. However, Newark has, if you look at this, the relative percentage of flights that are delayed for Newark seems to be quite a bit higher than they are for the other airports. And LaGuardia had the fewest flights of the 3 airports, but pretty clearly you can see that the proportion of delayed flights versus on-time flights, they had the best percentage of on-time flights. This blue part is a larger percentage of the overall bar than these are. You could actually display this a little bit better as percentages on the axis here instead of as bars. And you could actually put this in. There's probably an argument. You could look it up in the help on how to use geometric bar, ggplot, how to use ggplot, to see if you couldn't get this to display as percentages rather than as absolute numbers. I'll leave that up to you guys.